Mm.
So today we will do some basic exercises.
Okay.
Okay. Uh, Let us start from, let us see what making a map includes.
I think the basics we have covered. Maybe we can go from intermediate, like making a map. I have done that with you, like air quality and stuff like this.
Okay.
Yeah, working with terrain, WMS data. I guess yeah, it's fine. Working with projection.
So there is this thing that is called as heat map. Do you know
Mhm.
what is a heat map?
Uh, like it will be around. It will be like the amount of world temperature in, and we get a map. Like
Okay.
um,
So
so.
what we can do today is let
Okay.
us try to understand what a heat map is,
Mm-hmm.
and we will do this exercise.
Mhm.
So in today's time, there is like this is a very hot topic. Uh, Heat map, yes, research papers. So if you see, there are a lot of research papers that people have created using heat map. Okay,
Mm-hmm.
so what happens is, if you see all these maps, something might look very common. That is, these maps are created so that wherever the intensity is more, the color is different.
Mm-hmm.
For example, consider this to be maybe this is traffic congestion map.
Mm-hmm.
So this red thing shows that traffic is very highly congested.
Yes. Yes, I got it.
Yeah, but these are not actually points, but this is a
Da da da.
map.
Mm-hmm.
It is a raster.
Mm-hmm.
But so, for example, if you look this one, maybe this can be something like uh, cyclone density or something like wind density. Okay,
Kernel.
so every heat map can be used to represent different kind of data, but
Mm-hmm.
it depends on the intensity of data. For example, uh, this can be the population of Asians in the US. Okay,
Mm-hmm. Mm-hmm.
so Asians are more living in these regions.
Mm-hmm.
So you can understand it using this heat map.
Okay.
So if you go to the basic definition of what is a heat map, it is a data visualization technique that uses color coding to represent magnitude of density values in a data set. Got it?
Mm-hmm.
So anything where the data has some
Yeah.
variations, for example, population, pollution, uh, water contamination, anything that can be represented by the intensity or density, right? So that can
Mm-hmm.
be represented into a heat map. And obviously, why we call it as a heat map is because it resembles the map of surface temperature,
Okay.
right? So if temperature is more somewhere, the heat map will be. The map is created in that kind of data is the same we are creating here, okay?
Okay. So it will be the example of thematic mapping, heat mapping.
Yeah,
Okay.
theme-based thematic mapping, yeah.
Okay.
So now let us do this example of heat maps. In this
Mhm.
tutorial, there is one thing also that we will understand the concept of weights. What is weights in GIS? Okay.
Okay.
Uh, okay. Just visit this link.
Mhm.
Just open this along. Oh, okay.
Okay.
So first of all, there is this data that we will work on. That data is from the UK police. So we can, if you want to have a look at the database, you can visit data.police.uk. Otherwise,
Mhm.
you can directly download the file from here. This point.
CSV.
Just click on here and the file gets
Mhm.
downloaded. So if you see it is a comma separated value. Do you know what a CSV is? What is the difference between a CSV and Excel?
Ah.
Huh?
Mm. CSV is, I guess, is a type of format which we can import into GIS software, right? Comma.
So
Mhm.
what happens is, for example, if I save something, I write something here, maybe I say A, then I
Mhm.
say 1, then I say 5. Okay. Now
Mhm.
what happens is, here in Excel for human understanding, there are boxes, okay? But it
Yes.
is not for machine to understand it. Machine will get kind of difficult for it to understand what is boxes, okay?
Mm.
So for machine, there is a format similar to CSV in which the values are separated by a comma.
Okay.
So the first box would have been crime ID, then the second box would have been month, then reported by. So
Ah.
these are all columns, but here they are separated by comma. These are
Comma.
all the values, but here they are separated by commas.
Got it.
Got it?
Yes.
Okay. Just a minute. So what happens is because Excel is difficult for softwares to read, we always use CSV, though there might be option to use Excel also, but that will be probably the software is first converting Excel to a CSV in its function itself. Okay.
Okay.
So
And in order to use Excel sheet or Excel file in GIS, we should have like longitude and latitude, longitude and latitude.
yeah, yeah. We need to have some special reference that is latitude or longitude, right? Or something, it can be just X and Y also.
Yes. But we
Okay.
must have that, right?
Yeah.
Mhm.
So in this file, if you see, there is longitude as well as latitude. Got it?
Latitude. Yes.
Here is the value. Now just open your QGIS. Before we do this exercise, do you remember how to take out NDVI?
Yes.
Can you do it on your
NDVI.
own?
Yes, NDVI minus that, NDVI plus that divided
But
by.
can you do it
NDVI.
on your own?
Yes, NDVI, I have done that
Okay.
in ArcGIS. Yes.
And what about in QGIS?
Uh, I guess I can do that because it's just a one formula. We can put that. If I know the bands, then definitely I just have to put the formula, and we can then change the symbolization whichever we like, and it will give a value from -1 to 1. 1 means there is a heavy vegetation from 0.1 or 2 until 1, and from 0.2 into minus value, it shows that the vegetation was not there. Might be water or something else. Bad vegetation.
Okay. So first, go to XYZ tiles and uh, add
I
a
add the
open
Bing
drag a
maps. Yes.
pardon.
I add the imagery base map.
Yeah, the open state one, right?
I did the Bing map satellite imagery, the green
You
one.
have big maps in XYZ?
No. I think no. It's word imagery. Like I guess it's not there. Okay, I will add the OpenStreetMap.
Yeah. But what is the source of your Bing map? Like, where did you find it?
From like Quick Map Services.
Okay.
Okay.
Either is fine, but for this, let us just look at OpenStreetMap for now.
Because for Bing Map, maybe our heat map will not be visible.
Yep.
Mhm.
Now, there it says, switch to the delimited text lab. Here you will find import the CSV. Now, in QGIS, if you go to this data management option here, here you will find this delimited text. So this is for CSV. You need to connect your CSV here. Once you
Okay.
connect it, now the main thing is, first of all, to know that because if you remember, there were two columns that was latitude and longitude.
Mm.
Now here is an option that we can select from the attributes of the CSV. So X should be longitude and Y should be latitude. But
Latitude.
QGIS by default picks it up if the name is longitude and latitude, right?
Yes.
Then you can now visualize your data here. If you look here, You can see the data in the CSV data in an Excel form here. Okay.
Mm.
So make sure that you choose WGS84. That is here WGS84 for now. And press OK. Add. Now if I zoom in here, can you see the spots? These are
Yes.
all points where some kind of crime took place.
Mm.
Okay. So you can very
Yes.
well see from your bare eyes and understand, okay, the density of crime is high somewhere, low somewhere, okay? So,
Yes.
but we want to create a proper map out of it, okay?
Mm-hmm.
Now, so first, in symbology of this point layer, that is when you right click and in properties, there is symbology.
Yes.
Or maybe other than symbology, if you want to open it right, just select it and there is this layer styling panel. Just click it. So it will open like this. So in this single symbol, I want to change it to look like a heat map. So once I select a heat map, it will change something like this. So you saw it forms a cluster of things. Okay.
Mm.
So this is like a basic, very basic heat map. We want to change it into ways. Uh, there is something called as weights. I will explain. Now we can change how it looks. The author here chooses this red one. Now what happens is because how the algorithm to convert this points into this cluster works,
Mm.
it is based on the radius. Radius means like, for example, if two events are 50-meter away, should they
Mm-hmm.
consider should they be considered in one single dot or should
Yes.
like in a one big single dot or should they be considered separate? So
Mm-hmm.
the reason why this is separate from this is because some radius.
Really. Yes.
Okay.
Mm-hmm.
Now, when we choose heat map, we have the option of that radius. Okay. So
Mm-hmm.
based on the units of this map, we choose 5000 meters as radius. So we change this to 5000. It will regenerate the heat map.
5,000 millimeters.
Sorry. 5000 meters.
Mm-hmm.
Right?
Yes.
So for example, if you had made it like 20,000, see the
Mm.
radius. Now it is all considering it all to be one single uh, shading, right?
Yes.
So we chose 5000. Now the next step is just make sure at the bottom the coordinate system selected is 3857.
Yes.
Okay. Now in this only itself, there is something called as layer rendering.
Hmm.
Now in layer rendering, we are able to change the opacity. So if you see now, you are able to see the base map with the data itself. So now you know all the location also, right?
Yes.
So it says if you want to create a very simple heat map, so for many type of analysis, just considering the density of points is good enough. So if it is like a very simple heat map, you are done with the heat map. That is it. Okay.
Okay. Okay.
But sometimes there is something that comes into role that is called as weights. So what it means is, uh, to explain this, I gave this example. For example, if I talk about someone's personality, right?
Mm-hmm.
So there can be features about how tall he is, how how does he look, how does he speak. So these are all traits of personality, okay?
Mm-hmm.
But the thing is, uh, for example, if you're choosing a profession, for example, you want to be uh, a radio jockey, okay?
Okay.
So if you now think of those personality traits of that person, do
Mm-hmm.
you think how he looks matters now,
No.
right? So
Yes.
there are some traits that will be given importance, some traits that will not be given importance.
Mm-hmm.
So there will be a difference of the importance given to each of the traits,
Okay.
right?
Yes.
So, for example, if someone wants to become a TV actor,
Mm-hmm.
uh, then he should probably have, uh, like, he should nearly have all the traits to be good, right?
Yes.
So, for example, if someone wants to become a writer,
Mm-hmm.
does it matter how he communicates? Does the his communication trait or how he looks, does it matter?
No.
Right?
Writing. Yeah, writing matters.
So, uh, now we were just saying like basically yes or no, but there are sometimes you can uh, you can give a scale to the traits. Maybe if I say he wants to become a TV news anchor,
Mm-hmm.
then looks, yes, it matters 10 out of 10. Okay, how tall he is, you can say okay, it does not matter much. I will say just 4 out of 10.
Mm-hmm.
So every trait can be given a
Yes.
importance factor.
Yes.
So the weights work similarly.
Mm-hmm.
What it means is when you are doing some analysis,
Mm-hmm.
on that analysis, how the thing affects that analysis.
Okay.
For example, if you are talking about landslide, hello,
Yes, yes.
if you're talking about landslide, the slope of the rock surface matters very much.
Mm-hmm.
Whereas the sun angle on like the shade of the place or like how much sunlight it is getting, it does not matter that much, right?
Mm-hmm.
To the extent which slope matters. Okay.
Yes.
So while you are doing some analysis, everything has an importance factor that we call as weights. So, uh, based on the weights, there is a mechanism like in almost everything in GIS, we can add weights to get our visualization. Now, how that is working in this case is if you go down in this data
Hmm.
and open the attribute table, okay?
Yes.
So if you look here at the crime type, so some crimes are more dangerous than the other crimes.
Hmm.
Some are not so dangerous.
Hmm.
So we are saying we, because of the crime danger level,
Hmm.
we define the
Weights.
factor of it, like the weights of it.
Yes. 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 Yes.
So maybe in one region there have been maybe just consider two areas. One
Hmm.
is so maybe this is A and this
And
is some region B.
can we also like weight it in terms of location? For example, in that location, that crime was uh, like reported it twice or thrice or every single day, and in those areas, the crime rate are low.
I didn't understand.
So, like we can, if we can wait on the basis of location. For example, um, in the city center, there are high crime rates, and in like the suburbs of the city, the crime rates are low. We can also wait like this or not.
Yeah, yeah, yeah.
Mm.
So, for example, here, uh, maybe this is some house. So maybe this is a region A.
Mm.
So here you have two crime points. Two crimes happened over here. And this is a region B. Two crimes happened over here. Now here the both crimes that happened were one was cycle theft
Mm.
and one was robbery.
Mm.
And here both the crime was murder.
Okay.
So if I represent this area without in heat maps without any weightage, this will represent these 2 points to be equal to these 2 points, but that is not the case, right?
Mm.
Right? So you
Mm.
need to kind of give them a measure their of their dangerous
Significance.
level.
Yes.
Just, no, no, this time the flu, it is not going away.
Yeah. Because yesterday I also failed with no.
So
Is it cold in India as well?
it is around 12 degrees.
Ah.
Yeah. Okay. Mhm. So to solve this, We have a method in QGIS as well as ArcGIS.
The weightage?
Yeah, the weights.
Okay.
So what we do is, first of all, we will add a new column.
Mm,
So let us here go to the field calculator and add a new column. Let us call that column as the weight. Okay. Now, the author uses this formula. What this formula means is, because if you remember, QGIS has its own inbuilt language, right?
yes.
You can use Python in the Python code editor of QGIS, but in the calculator of QGIS, it has its own way of doing things. So
Mm-hmm.
to add weights to some data, you can always use this thing that is called as case. So what it means is, if you remember, just like in Python, we had if and else.
Yes,
So
yes.
similarly, there is something called as case in QGIS conditionals.
Mm,
So you just go to conditionals here, and here is the case. So when you double click it, it will add here, but uh, you have to add the condition here. The condition is not yet added here, and the result here. So I clicked it, it gave me the formula. Now the author has
mm, in
modified this formula. So it says when
crime type
the
is
crime type is starting
violence.
from the word violence,
Mm,
then 10. When
mm,
crime type is starting word from the criminal, then 5,
mm,
otherwise 1.
one.
So what it says is, if you look here, there are like crime like this. It says if starts from the word violence, it should be,
Violence. 10.
it is 10.
Mm,
If it starts from the word criminal, for example, criminal damage and arson,
mm,
then weight is
5.
5. Otherwise, the
Other.
weight is 1.
Mm,
So if it
5.
is Bulgari, public disorder or order, that is just 1.
Mm,
Okay.
yes.
We just copy this and paste it here. After pasting, just press apply and OK. Now, if you see, there is a new column added here. That is the actual weights. Okay. So violence and this is 10. Criminal damage is 5. Public disorder is order is 1. Right? Got it?
Where
Hello,
is?
hello.
Yes, yes.
Okay.
Yes. Got
Okay.
it.
Now, based on the weight, we will bring some changes in the heat map.
Mm-hmm.
Now, if you go back to the heat map, there is this option about weight,
Points. Yes.
weight point by. So in here, you have to select the weight. Okay.
Hmm.
Now what happens is, uh, because this is kind of grading the color of the area, right? So when a crime is 10, it will more readily change to color red.
Yes.
Where when it is near 5, it will be still more stable than red. But if it is less, it will be whitish.
Hmm.
So there is this reference. Now, just simply press OK. Apply is already there. Now you want to kind of what happened is you have visualized it in heat map form, but you have not created an actual raster. So if you want to pass this data on to someone else, right? If you want to give him a heat map,
Hmm.
okay, then in the processing toolbox, because
Reproject.
whenever you work with a raster,
Hmm.
you need to make sure that you are working in the projected coordinate system. Why so? Because in geographic coordinate system, rasters tend to give some error, big errors.
Hmm.
Okay. So, first of all, before we convert it into a raster, we need to reproject into the UTM system. So just go to the look for in the project processing toolbar, just look for the reproject. So if I go here and look for reproject, so I'm changing the coordinate system from geographic coordinate system to projected coordinate system. Okay. So in the uh, vector journal, just click on the reprojected tools. Select the 27700 coordinate system. Here it is.
Hmm. Where did you find from input?
Your voice is not coming.
Uh, from target on target. Uh-oh.
Yeah,
It's
target.
27700. 27700. It's British National Grid.
Yeah,
Uh,
simply press run.
it's not selecting for me.
Huh?
Okay. After this, what I have to do? Hmm,
So after reprojection,
just run.
pardon.
Yes, done.
So after reprojection, now we want to create a heat map, actual heat map, so that we can kind of give it to someone else the data. So before we just use the application of QGIS to visualize it. Now we are actually producing it. So just look here for interpolation, and in interpolation you will find heat map.
Hmm.
So in heat map, first of all, change the radius to 5000, right? And pixel as small you can make, the more the clarity. The author has taken 50, just change one value and everything will change. So you can take even 25, 20, that will be make the image more clearer. Okay. So if I take 50 here,
For
and
me,
now there is,
radius was degrees. I don't have option.
you don't have the option to change the radius to meters.
Oh wait, I guess it's heat map. uh, for me, it's yeah. This it's only showing degrees.
Degrees.
Hmm.
Did you change the coordinate system, target CRS?
Yes. Uh, okay, okay. You are using reprojected one. Okay, I selecting the other one. Sorry.
Yeah, yeah. If I choose the other one, then it will come in degree, that
Degrees.
only, not in meters.
Hmm. Okay.
So got meters now?
Hmm.
Okay. Just select the weight from the field. That is the weight file. Okay.
Hmm. What is kernel shape?
So what happens is, this will come in overlays.
Hmm.
Um if you see a raster image, right?
Mm-hmm.
So this is a raster image. It has pixels in it.
Yes.
So what kernel is? Kernel is like a this grid. Any size of grid is called kernel.
Mm-hmm.
You can call it kernel or kernel. Okay. So
Yeah.
a raster is basically a kernel only. Okay.
Mm-hmm.
A combination of grid, right? So,
Yes, got it.
so what happens is when we are doing this weights operation,
Mm-hmm.
uh, there are some inbuilt algorithms
Mm-hmm.
in which it depends what we are choosing for the kernel shape. So for now, it would be difficult to go into what kernel
Mm-hmm.
output will give that, but just the definition of kernel is it is like a grid.
Okay.
So don't worry about what functioning it does. So we just simply press run. So once it is complete, it will show up like this. Now you can, now this is a raster. So you can symbolize it. So you can symbolize it as you want. Got it?
For me, it's why not from bad one?
Hmm?
For me, it's empty.
What is empty?
Uh, the heat map.
Did you choose weights?
Yes. We don't try again. Reprojected. Radius 5000. Pixel size 50. Weights, yes. Quadric.
Maybe if you can share the screen.
I will do that. Yeah. I,
Uh,
this is fine. This is reprojected. It is 5,000 meter. Exam size 50. Weights. This is weights.
just in pixel, remove all the zeros, just put 50. And on the other side too.
This
Okay.
one.
Comes by default.
Yes. Should I run it?
Yeah.
Or have to save it anyway?
No, no, no need. Just run it.
Now it started running. Before that, it did not run like this. And it's empty. Yeah, now it shows.
So just go to symbology and you can change the color.
Mm. Huh? Shit. Shit, 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 shit.
Just press Control Z. Just press Control Z twice.
No.
No?
Yes, it's not working.
So no worries if it got okay, you can try again.
Okay, I mean, like, okay, perfect. No. Shit, shit, shit.
What is the RAM of your computer?
8, I guess.
That is why.
It's okay. Single bed.
In single band change to
I do not
no,
know.
change the single band gray to like single band pseudo color.
Redokuda.
Yeah.
Yeah.
Okay. Now
Yeah.
you can change the color M to any way you want.
Mm. Mm. There's also an option of like
What are you looking for?
that what you can, yeah, this one. All color lamps. That green blue. Ready.
Just click apply on the right side down.
It's already applied. Perfect.
Okay.
This is 0 and just nice.
Okay, then we are done with heat maps. The
Mm-hmm.
next thing is we will do one more exercise, but
Mm-hmm.
we'll take 5 minute break, okay?
Okay, no, please.
Okay, I'll get back in 5 minutes.
Okay.
Hello. 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 Your mic is mute, Asad. Hello.
Hello.
Yeah. So the next we can do try is there is this map of so the next we can do is this tutorial that is called as interpolating point data. So have we talked about what interpolation means?
Mm, no.
Okay. So here is the link. So what happens is if this is a if
Is
this is a
interpolation, sorry,
huh?
is interpolation is what do you consider this? LiDAR or point-based data, like,
Um, so interpolation means like for example how let me explain it in this way. Use my mouse. So maybe this is your some vector data. It can be
mm-hmm,
line, polygon, right?
mm-hmm,
So, but if you see here, you have a value at this point. You have a value at this point, but you don't have
mm-hmm,
values at these empty places. There is no value at
mm-hmm.
these empty places, right?
Yes.
So, what if I want to change this into a continuous surface that I want to create it into a raster maybe? So, similarly, in heat map, we had points and we created into a continuous surface, right?
Yes.
So it was basically interpolation only. So in interpolation, some algorithm is used to put some value in the places where there is no point. Got it?
Okay.
So if you maybe look at the heat map from the last exercise, when there were initial point of crimes that were not all over the place, right?
Mm-hmm.
When we created a heat map, the heat map has a value all over the area. So it
Yes.
is continuous and it has values at points even where there was no point value before. Okay.
Mm,
So interpolation basically the definition is using the existing points or line. It can be polygon. using the existing data to convert into a continuous data, by means of which what we are doing is we are giving values to points that did not exist, some values to the point that did not exist, and hence creating a interpolation. Got it?
Yes. Uh, like one thing, can I share my screen for a second?
Just a moment. Yeah.
Okay, like in this like heat map, I have a value from 0 until like 2295, right? And 0.86.
Yeah. Yeah.
But my weighted value was like 10, 5, and 1. But why is it showing like this? Did you get the point?
So it is like,
It should be around like this, nah? Like 10, 5, or 0, or vice versa, 5, 0, 5, and 10.
no, 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 no. It is, um, that was the weights. Weights is like the product. We did
Hmm.
not assign value to the crime. We said importance factor. So
Yes.
that factor was used in creating this data, not the actual value. We did not say the crime is equal to 5.
Mm. But the point was like we weight on the basis of crime or on the basis of like which type of crime was that, right? If
Yeah.
it's violence or something. But does it interpret the same result? Because our what do you say, analysis was a kind of like different. Like for if I talk about a random person, just see this map, will he will be able to interpret our results, what we are trying to figure it out based on these weights. Like if I talk about a symbol, if for example, if I saw that map and I don't know the logic or analysis behind this, I would just say is that okay, these are just maybe random points where anything could be possible, right? Did you get my point?
No,
What I'm
no. These are not random points. What is happening here is the if you see the bluer points,
mm,
what has happened here is
maximum
we
values.
have assigned it the maximum crime value.
Okay, the 10 one.
Yeah.
Hmm.
So in these areas, maximum number of crimes have happened.
Okay, and these like the yellowish one, this one was a
Yeah.
5 rating, right?
Yeah.
Violence something like that. And then a 1, 0 means a 1, like any
Zero
other.
means like near to zero, like almost no crime. But still, if you see, the red is from zero to something. So there can be a little crime.
Hmm. And what is like
So,
separated one?
we chose 5,000, right? So for 5,000, it created one body, but that body was coming out of the radius, so it showed it as a separate one.
Hmm.
If I chose 20,000, it would be a part of this one only.
Okay.
Got it?
But okay. The 5,000 radius will be like smaller, and 20,000 will be like this whole one, or maybe whole.
So for every crime point, if the distance between them is less than 5,000, sorry, if it is 5,000, they will merge into one crime, uh, like one crime area.
For example, this is one area, this is one, and it merged into in like one, right? Like this.
Yeah.
Okay.
but that one was completely far
Separated.
away. Yeah.
Um, okay, got it. So, okay, makes sense. But can we change these values like from 0 to 2000 something?
You can reclassify it.
Mm. Like the original values, like I decided in the weightage categories like 10, 5, and 1. So
Yes,
that
yes. So
mm,
just share your screen again. And in the processing toolbox, look for reclassify. Reclassify by table.
maybe this one.
Table selected. So in here, select the heat map that you produced, and then in the this table.
Well,
No, no, the next one. Yeah, this. Just go to the very right and click. So here, add rows, 3 rows, or as many as rows you want.
mm,
So for example, if you want, you need to add the index here. If you want 0 to 100 be shown
mm,
to you as 1.
mm. But now I don't know these
So for
values.
example, it is from 0 to 2 lakh something, right? So you can
Mm,
say like 0 to 50,000 should be 0,
yeah,
should be 0.
you know,
And for the next one, you can say 50,000 to 1 lakh can be,
like this.
yeah, 50,000 to 1 lakh.
50.
And there is no need to add 1 here
Yeah.
on the left one. Just add
Okay.
0. 50,000, no, it is 50,000. Just write 50,000.
1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5,
Okay.
6.
So add value 1. Similarly, you can classify it all, but I think the heat map goes into how much is this? 1, 2, 3, 4, 5. It is in crores. So
2
you
lakh.
can maybe in the
6.
third one say 1 lakh to the final value. Yeah, write the final value and say it as 3. 3.
3.
Sorry,
2.
2, 2, 2. Sorry, 2. And just run it.
List must contain a multiple of 3 elements. Found 1.
Huh? Multiple of 3 elements.
But we have 3 elements. 3 rows.
Maybe just go again in the parameters. Um, just go back from the, yeah. No, no, no. Yeah,
Yeah.
just go back here. Should work. I don't know why is it. Okay. Maybe go
Showing
to
me
the
my
table again
this.
and change it from like low to like delete these 3 columns. Just delete the first two first. Yeah, don't remove this. Add 2 new columns. Now say 50,000 to 1 lakh is 1. 50,000 to 1 lakh as 1 and 0 to 50,000 as 0.
1 lakh to 50,000. Oh,
No, no, we are going reverse, right?
then
If
1
you see
lakh.
from above. No, no, 0, 50,000 to 0.
Because it's one neck. Then
If you see on the third line above, it is 1
okay,
lakh.
okay, 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 okay.
So it will be 0 to 50,000.
Uh,
0 and 50,000. Try to run it now.
0, 0. Overlaps. I guess we have to add like one in between. It should be maybe like this
Okay,
50,000
maybe you can say
one.
1. Yeah.
Okay, then it should be okay. 49, 999, 999. Table finished. At why is 0, 0, 0? I guess we were doing right, but we were.
We chose the wrong order this time.
It should be like 0 to 50,000. 0, 50,000. 1 and 10. 1, 2, 3, 6. 1, 3, 4, 5, 6. That would be the value. 295. 2295.86. 792. 2. Still saying 0, 0.
Maybe I will check why it is not coming. Do not worry
Mhm.
about it now. Hmm, some kind of error maybe. Okay,
Mm,
anyways, you said like today you could only have 1.5 hour class?
yes, we have like 1 hour left
Okay,
until
okay.
20,
Until?
12:30. We have 1 hour
Okay, okay.
left.
So for me it is 4 right now. Okay. Okay. Then we will do this exercise.
Okay.
That is the
Interconnecting. But we did not do like nearest neighbor analysis sampling cluster data.
uh did we not
We
study
have done
this?
the table joins, special joins, special queries,
Have we done this?
vector based analysis, point and point. Yes, but on theory, not on the practical.
Okay.
Like on theory, I have like get these examples, but not on the practical side. Or maybe it's just like one special queries, right? In the geoprocessing tool.
No, no. What happens is there are, first of all, you understood what is interpolation, right?
Okay.
That you understood the part like where there are no values, you use interpolation. Okay.
Mm-hmm. Mm-hmm.
So interpolation can be of many types. Okay. So
Okay.
So if you see this, what is happening here is initially the person had some points.
Mhm.
It wanted to create a continuous surface like the one that it is shown below. So using these points, it created this surface. So that is called as interpolation. So there are many methods of interpolation. Okay. So first of all, if you look broadly, this is more mathematical in this one. So what I will do is, because it is given in very complex terms here, I will
Mhm.
create a PPT and in the next class we'll discuss about the types of interpolation. Okay. So in
Okay.
types of interpolation, there is IDW, Kriging, nearest neighbor, maximum likelihood, tin network. So these are all different kinds of interpolation methods. So these are algorithms that we use in GIS to find values. Okay.
Okay.
But today, let us just do this exercise to understand interpolation better. Okay.
Okay.
So just open the link,
Mhm.
and in this there will be this line. For convenience, you can directly download this sample data. Just download this data directly.
Mhm. One thing you also forget to share the e-cognition link.
Okay, okay. Uh, with Ignition, there was this problem that I don't have that much drive space.
Mm-hmm.
So it is more than 2 GB.
Mm-hmm.
Uh,
But you said that you will share a link to download.
no, I tried it on like Box. Dot. No,
Or maybe you can use WeTransfer. It's also free.
We transfer.
WE transfer. We. Yeah, the second one, yes. It's also free. Except Agree.
So I just add file here.
Yes. Or maybe add folder if it's one folder. If it's one folder, you can just open one, add one folder as well. It won't be automatically will be in zip file.
This was not anything I was looking for. But this, how does this work? We just
Mm,
get email to your email. What is your email?
M.
Can you type in the chat?
Okay. Mm, you can also do the alternative things. Okay. Agree.
It is very difficult to find e-cognition.
Mm, if I find that exercise where I was struggling, I will also share that thing with you. Because the thing was, I don't know if you know Professor Dick or Stephen, they like created that a task and and it getting more complex and complex if I go into the last task, which is task 3, to differentiate the ship from a river and stuff like this. Mm.
Don't they give video recordings of lecture?
Uh, in universities?
Yeah.
No.
Okay.
It's not allowed.
This is very slow. Maybe until that we can do this. So,
Okay.
did you download this?
I think so. Yes.
So, after you download, just maybe this is a zip
Unzip
file. Just
it.
huh?
Unzip it or
Yeah, unzip it. I think have you just look at it. Have you done this exercise before?
wait,
Creating a bathymetric. Have we done this before?
no,
No.
no.
Okay.
This will be the first time. So it's just a point data.
Yeah.
So it can be of LiDAR as well. That the point cloud data which we get from
Yes, yes,
LiDAR.
yes. It can be of LiDAR as well.
Mm. No, just get the transfer. It will get the transfer link. Yes.
So just uh, unzip it.
Mhm.
So once you unzip it, you can see there are three or four files here, three or four type of shape files. Now first we need to select is Arlington 2007 that ends with 83. There is one more file in the folder that is very similar to this one. Do not get confused. Choose this Arlington 2007. So there is one file that is uh, this one Arlington underscore something. We don't want this. We want the Arlington 2007 SHP. That is this one Arlington 2007. Select this and drag into your QGIS.
Uh, SHE 2007. uh, S83 STPL.
So just
No.
drag it into your QGIS. And this is points. So what is this? At every point, the depth of the lake has been measured by, it can be drone, LiDAR or any way, but they have the values of the depth of the.
Ah,
Now we want to create a lake out of these points. We want to create a digital elevation model of the place from the points. Okay.
yeah. But for me, it's not opening.
Choose this
It
one,
said
Arlington 2007. Don't choose.
yes, but it said inverse of Texas transformation.
Can you share screen?
This one showing.
Yes, yes. It asks you to add the coordinate system. What you can do is, wait, just stop sharing your screen. I'll tell you. So just select the first one. So
Inverse.
it,
Okay.
yeah, it is asking for the coordinate system. Just select the first one and press OK.
So to
Then locate the other shapefile, that is boundary 2004, and add the shapefile to your QGIS. So this is the boundary of the lake.
hmm. So this is very accurate depth.
Yeah.
Nice.
Just for the while turn off the boundary. So in this lake, right, there is one patch of land. What there are two patches of land. What land means is, so at every point on the lake there is a depth, but on the land it will be flat, no values because it is not a depression, right? It is
Hmm.
plain. Got it?
Okay.
So there is a shapefile that is island. We select the SHP of island and add it to our QGIS. So you can see the islands are added, and wherever the island was there, there is no value of observation.
Hmm. Yes.
Now what we do simply is, uh,
But we have also small gaps. Other ways as well, small.
yeah,
Uh, can I share my screen?
yeah.
Okay. Like here. If I turn on Iceland, only these two places have Iceland. Apart from this here, and here.
So that is more like how to say the, if you zoom in, you will find more gaps. Actually, the person who took the data, he
Hmm.
has taken the data like this. So uh, it could be a uniform data also, but sometimes there are difficulties but because of which we cannot take complete data. But in interpolation, what happens is whatever data we have, based on that also we can kind of create a value for the place where there is no data. Okay.
So what is the name of this the data? Point cloud or what?
This is simply point cloud only, yes. So every point, if you go to the attributes table and check,
Hmm.
every point has a elevation attached to it.
So in terms of drone, how can like get the data from the sensor, or we can also done from the random simple what you can do is MRV, like multi-resolution camera as well, MRS, or it's a special sensor which like get the data.
So we can get the data from multispectral as well as we can get the data from the LiDAR also if the drone is attached with LiDAR. So
Mm.
what happens is, uh,
But in multi-resolution, I guess we just have the imagery. We don't have these like point cloud.
we can get point clouds. Uh, it is
Okay.
like the option is there to
Hmm.
extract point clouds, but we generally don't do that.
Hmm. So
So
it's also working like it just like work with the simple like uh, what you can say this a simple satellite data like it sends the radiation and then it come back from the surface after it's reflected like this.
pardon.
So the phenomena is the same like uh, we studied in the uh, satellites class that uh, it send the signal into that place and then after reflected it get the back the signal and then it calculates the area of these.
Okay. So what happens is, let me explain you. So
Mhm.
just imagine that you had only one eye, okay, not two eyes.
Okay.
And if the curvature of it would be your eye is round, what if it was flat? Okay,
Mhm.
then what would have happened is if you are looking at anything right now, anything in your room,
Mhm.
you with your brain are able to apprehend how far that thing is away from you, which things
Yes.
are near to you, which things are far from you,
Yes.
right?
Yes.
Why are you able to do that?
Mm.
So what happens is that is happening because you have two eyes.
Yes.
So what happens is uh, there is a concept. For example, this is an image of a place, and maybe the drone take took this image, okay?
Mhm.
And in the next step, the drone took, and the next step, drone took this image.
Yes. Yes. Indeed.
Now you
Uh,
see that there is
overlap.
an overlap,
Yes.
right?
Yes. Yes.
Now what happens is overlap is basically just like your eyes looking at the same place from two different angles. Before the camera took at image at this place, it was here, the drone.
Mhm.
Then the drone moved to this place and it took this image. So it
Mhm.
it is like two eyes, right?
Yes.
So now what happens is it is the ability, or you can say similar ability to human. Based on that, when we look at a same thing
Mhm.
from two different angles,
Mhm.
we are able to apprehend the 3D of that place.
Mhm.
Got it?
Mhm.
Why it is so is, uh,
But if I close one eye and if I look into different places,
uh
but still It's the same thing. Oh, no.
I told you because the curvature of your eye is round. If it was to be
If it.
flat, okay.
Ah.
So
Okay.
by capturing two images of the same scene from slightly different viewpoints, mimicking human binocular vision to create a 3D effect of depth perception when viewed together. Okay. So
Hmm.
actually, this has been sent to you. Did you receive the email?
Yes. I started, yeah, downloading it.
Okay. So basically, what happens is the science behind it is that uh,
But maybe like in next class we can do the theory like with
no.
interpolation.
What happens is you are looking at one thing.
Hmm.
When you look at it from one angle and then you look it from another angle,
Hmm.
your eyes are able to comprehend to look at, create a difference in understanding that before the image was creating here and now the
Hmm.
image is creating here, and your eyes, because the eyes are they are getting, your two eyes are getting two different images, but they are
Yes.
clubbing it into one image.
Image. Yes.
So there is a mechanism that is happening. What it does is it is able to give you depth perception. So because
Hmm.
from if you close one eye and then you look at the same object from another eye, you will see
Hmm.
that there is a difference how it the image is created of that object.
Yes. Yeah. The
So
scope, the length will be different.
yeah,
So, how I can say this? Like the diameter is different. Like from one
yeah,
eye, I can see less. From other eye, I can
yeah.
we see the other.
So when
Mm.
combined, there is this thing that is making us able to kind of percept the 3D nature of it, like how far it is away from us. Okay.
Yes.
So similarly, when we have any wavelength or any satellite, so when we
Mm.
are overlapping it, or if we are doing it from drone, when we are
Mm.
overlapping the image, because in drones we overlap the data.
Mm-hmm. Yes.
So when we are overlapping it, we are able to get the 3D perception of the ground, and from that perception, we are able to tell how far it is away from the sensor, that is the eyes. Okay.
Mm. But it's comes in the format of imagery or okay, you already told that we have the option. Okay.
Huh?
So
Pardon?
we have the option to get it in terms of
Yes,
point
yes.
cloud or yes, got it. Or image.
So what happens is,
It's continuously like overlapping of the area.
so if you have like a 10 centimeter scale in front of your eye,
Hmm.
you are standing here, and when you look at a 10 centimeter scale here, it will look bigger as compared to a scale that is of the same size, but when it is here. Okay.
Yes. Hmm.
So what happens is, now you know, in your mind is not that mathematical, but in satellite you can set a standard where you can understand if the object looks this big, that means it is at a distance of this much from the. If a
Hmm.
10 centimeter object looks this big, it means it is at this distance from the satellite. If it looks so small, it means it is at this distance from the satellite.
But the sensor can sense it, na? The radiation or when the
So,
radiation.
so the sensor interprets it from the imagery itself.
Hmm.
Okay.
Okay.
Okay, let us write down two things. One is interpolation, and another is stereo pair. So we will discuss their theory in detail also.
Okay.
So here, just go in the processing toolbar
Hmm.
and look for interpolation. And in interpolation, you will find tin interpolation.
Hmm.
So just select double click on tin interpolation. So tin interpolation basically means is you have some random point values. Okay.
Hmm.
The way it is here in this, the way it is here, right? So you have some values. You want to convert it into a raster surface, but the tin interpolation is an algorithm that first it will convert it into triangulation, triangulated irregular network. What it means is it will create polygons that are triangle. So based on these points, it will create triangles
Okay.
so that the whole surface is covered. Now once the triangles are created, then it will convert it into a proper raster with values, with the a value at every point. Okay. So there is this algorithm. Do not need to go into the mathematics of the algorithm, but it creates a triangle
True.
irregular network. So just select tin, and in tin select the vector layer as Arlington, that is already selected, and the interpolation attribute as elevation. And then click on the add layer. So what I'm saying is I'm performing the interpolation. I'm saying the interpolation should be based on the elevation points. Now I
Mm.
want that there should be the, so there is one thing that the elevation should be based on these points. Then there is another thing that I want is that uh, if I choose here the island, so in island, I don't want the island to be represented because the island has no points. So in that case,
Mm.
I will call it break lines. So what it means is wherever there is island, it will do not perform any interpolation. Whereas it will perform interpolation here also, but because I'm specifically saying that at island break lines, okay?
Okay.
Break lines means do not perform an interpolation there, okay? Just press run. Before run also, just a moment. Yeah, we need to define the extent, and in extent here, calculate from the layer that is boundary. Pixel size should be 5 pixel. If you want to save it, you can save the data here. And when you run it, you will see it created a kind of elevation model, digital elevation model of the area
Mm.
from the points. Got it?
Yes, yes, yes.
Now, because there is some additional interpolation that happened, that is this regions. We don't want the value at
Mm.
these regions. We want to, we will cut them out. So what we can do is we can look for clip raster,
Yes.
and we can go by clip raster by mask layer, I think. And in input layer, I will choose the interpolated, and in mask layer, the boundary. And run. So if I see now, I have the exact area. Got it?
Mm. Yes. But it's same like them.
Yeah, it is a DEM.
Okay.
There's no difference in the DEM and this.
Ah, huh. It's okay.
So now you know how DEM is created from a satellite imagery, right?
Yes, yes. And these values are in like 550 and the It's point or it's 5 lakh
No, this is 550 meters. Uh, this
and
is the like uh, the depth, like it is taking from the ground level. What it means is, if the ground is at zero, this lake is a little above some surface. Like it is a city that is at a range of 500 meters above the sea level. So this is that city. This is zero sea level. So in this city, there is this lake. So the lowest point from zero is
mm,
502, and the highest point of the lake from zero
5
is 550.
sea
Got
level,
it?
below sea level, right?
Yeah, yeah.
Mm,
Got it?
yes, but that okay, yes. So it's DSM or it's DEM? DEM,
Right. It is probably DSM
but it's not calculated on surface. It's
because there is
below.
no buildings or
Yeah, but it's then DEM. Surface model in, I guess in surface model we have the surface above surface.
so you can just
If I
there is this definition here, DSM. This is, I won't call it a, no, it is by principle, it is something like a DEM, but I won't call it a DEM because there are different algorithms on how we can create a DEM, right? So
okay.
on it, by journal definition, it says that DEM flattens out the water surface.
Mm,
So if it is from a satellite or somewhere, it might flatten it out as completely one proper land, equal elevation land.
mm,
Okay.
mm,
But
yeah.
we have done it for our understanding. The thing is,
Mm,
the product is very similar. It is almost same as DEM. Okay.
yes.
Okay. So I think today it is enough already. We will discuss those 2 points. You have got the data already, right?
This one, yes, yes.
And I shared one book. Did you have a look at it?
Not now, but I will do that in the like weekend. I receive
There
it.
there is one more book also.
Mm,
This one. This is a very, very good book.
okay. So the interpretation is done in this, or there is also we can do that.
No, no, I have written it down. We will do it in more explanation. Okay.
Mm,
But
okay, okay, okay. After this,
you,
they just change the symbology.
yeah,
Okay.
but you understood what interpolation is, right? You can
Yes,
just
yes, yes, yes.
change it like you can change it to
Mm,
anything for better understanding. So
okay.
the lake is more deep here.
So they just change the symbology into this and then label the features depth. Hmm. Nice.
So just go through this book. This is like a very good book, but it is mostly based in ArcGIS. But for your
Okay.
course, what you are doing, I think it will be very helpful, very, very helpful,
Mm,
because it has practicals that includes the photos with how to do in ArcGIS
mm,
and the if you go to the index of book, so here you have anything you want to
um,
read about DEM,
ah,
LiDAR, 3D models,
mm,
you can just
got
look around.
methods. Perfect.
Okay.
Mhm.
Okay, then I will see you on Sunday, right?
Yes. Which time? 10 to 1 or?
Sunday, oh, Sunday actually I'm traveling maybe.
Hmm.
Uh,